Good morning, everybody, and thank you for joining this analytics webinar today. So our presenter, Hemi Baldock, will be covering microwave extraction for organic pollutants. We will have time for question and answers at the end of the presentation, so please type these into the Q&A box as we go along. This event will also be recorded, and the recording will be supplied to all attendees following the session. So now I will hand over to Hemi. Thank you.
Good morning, everyone. Thank you for joining our webinar today titled Efficient Sample Preparation of Environmental Organic Pollutants via Microwave Assisted Extraction. My name's Hemi Baldock, and let's crack on. So on today's agenda, I will be covering why environmental monitoring is important and microwave assisted extraction as a technique. Specifically, we'll talk about the use of the Milestone Ethos X platform with the FastX24 rotor. We will talk about the workflows using this system, and then we'll go into some real-world case studies talking about microplastics, dioxins, and PFAS analysis. So let's start by talking about environmental monitoring and microwave-assisted extraction as a technique. The environmental testing industry and research is one of the largest users of analytical instrumentation, carrying out important work leading to the monitoring and control of pollution, with the ultimate goal of protecting human and environmental health. Environmental analysis could include the monitoring of remediation processes, contamination in waste, landfill waste, or general environmental monitoring, studying of trends. The modern lab is under greater pressure than ever to deliver accurate results at lower reporting limits. Special emphasis is made on productivity to keep up with an extremely competitive market. Today, we're going to focus on the extraction of pollutants from solid matrices. This is often performed with techniques that offer limited productivity and have high operating costs. Solvent extraction is the least evolved and most error-prone step in pollutant analysis, with many methods using this technique dating back to the 1800s. A way to overcome these challenges is by utilizing microwave-assisted extraction. This technique for extracting contaminants from solid or semi-solid samples using a liquid solvent. Microwave-assisted extraction uses closed vessel systems where high temperatures and elevated pressures with a common solvent can increase the efficiency of the extraction process. This offers faster extraction times while producing more accurate and precise results compared to other sample prep methods. Microwave-assisted extraction can be used to replace socculate, sonication, boiling, or wrist shaker techniques, to name a few. So when you're extracting with a solvent at these higher temperatures and elevated pressures, there are two fundamental advantages. Firstly, you'll have better solubility of your analytes into the solvent. For example, let's take anthracene, a small PAH compound. This is 15 times more soluble in DCM at 150 degrees versus at 50 degrees. While solubility is increased, you also lower the viscosity of your solvent, which enables better penetration into your sample. So the results of this increased solubility and reduced viscosity ultimately enhances the extraction efficiency and reduces extraction times. This makes microwave-assisted extraction a fast and effective approach to sample preparation for organic pollutant analysis. So here I just wanted to cover a comparison of factors involved in sample extraction from a number of different techniques. I'm going to focus on the far right-hand side column for microwave-assisted extraction, abbreviated to MAE. This technique offers the most flexibility in sample size while using low volume of solvent per sample. You have the ability to simultaneously extract 24 samples in 40 minutes, offering high productivity over an 8-hour workday. At a moderate initial investment value with low operating costs per sample, microwave-assisted extraction as a technique provides high-quality data, high productivity, and a great return on investment. So now we've covered the background of microwave-assisted extraction. Let's specifically talk about the milestone Ethos X system. The Ethos X system delivers high microwave power, resulting in faster heating and shorter extraction times. Robustness and reliability are essential characteristics in environmental labs to avoid any lapse in the daily operation. The Ethos X has a rugged stainless steel construction to ensure a longer lifetime and to eliminate downtime in the lab. The Ethos X with the FastX24 rotor allows for simultaneous extraction of 24 samples in 40 minutes with minimum solvent usage. Using large volume disposable glass vials, the FastX24 rotor simplifies handling and allows users to achieve lower detection limits. On the lines of simplicity, the extraction methods are controlled by the touchscreen terminal, which can be seen on the right of the system shown. The Ethos X with the FastX24 can be used for extraction of water-insoluble or slightly water-soluble organic compounds from mediums such as soils, clays, sediments, sludges, and solid wastes. In fact, the Ethos X with FastX24 rotor can be used for solvent extraction of a range of compound types, to name a few but not limited to chlorinated pesticides, SVOCs, PAHs, PCBs, dioxins, and furans. Another point I wanted to quickly touch upon when talking about the system and the rotor specifically is the use of disposable glass vials. Disposable glass vials prevent the requirements to clean between runs, and the memory effect often observed when using polymer vessels or other technologies is eliminated completely. This is a valuable feature for trace analysis of challenging species such as dioxins. The large volume 100 milliliter vials can accommodate between 2 to 30 grams of sample, offering labs a wide sample mass range, enabling lower detection limits with minimum solvent usage. Although here I mentioned that these are disposable, these can be cleaned and reused depending on your application and what you're looking to achieve. So let's talk about the workflow of the system. This can be broken down into 3 simple steps. The first of this step being the preparation of your sample and rotor for the extraction. So here, all you need to do is simply load your samples and weigh them directly into the large volume disposable glass vials, add an appropriate solvent mixture, then you add the Weflon heating badge, followed by the glass vial, which can be seen here. The Weflon heating ring ensures homogeneous heating in all the vessels, increasing the extraction efficiency. Also, at this point, you do have the option to add magnetic stirrifly for better aiding of extraction even further. Then simply place the cap and the lid on top of the vial, which can either be hand tightened or tightened using a dedicated tool. Something I wanted to touch upon here is the recommended solvent mixtures. For extraction, solvents are typically include acetone combined with either hexane, DCM, or toluene, dependent on your target analytes. The key when using microwave-assisted extraction is to always have the presence of a polar solvent to interact with the microwave energy. When we are using less polar solvents, such as toluene, for example, the Weflon badge helps with providing homogeneous heating and supports the extraction. We do have a wide range of application notes detailing recommended solvents chemistry for a range of application areas. So if you require any support on your current extraction techniques, do please feel free to get in contact. These are available on request. The second step in the process is to set up and run the microwave program. The user terminal runs an icon-driven multi-language software with preloaded extraction methods. Using the touchscreen, the operator simply needs to select a method and press start to begin a new extraction process. The extraction parameters are displayed in real time on the terminal and can be stored and transferred via USB or LIMS systems. Here you can see an example of a microwave program, which typically runs for 40 minutes. Here you have temperature on the left, time in minutes on the bottom, and then microwave power on the right. Here you can see the microwave program heats for 15 minutes to 110 degrees. This is then held at 110 for 15 minutes and allowed to cool for a further 10 minutes. And here you can see the microwave power fluctuating as the heating program progresses. So just to touch on that now, the system is equipped with contactless temperature sensors that can control the temperature during the whole extraction process in all the vessels. The microwave power will adjust, ensuring that the heating of the vessels follows this desired program. This provides high safety and reproducibility. The use of a non-invasive sensor in combination with the Weflon badge simplifies the user operation while delivering accurate temperature control. Another thing I wanted to touch on about the software was that several official methods describe the use of microwave assisted extraction technology to enhance the extraction efficiency of organic pollutants, one of these being the US EPA 3546 method, as well as many ASTM and other national methods as well. One of the many useful features of the software is the built-in parameters for these official methods. Here you can see the example of the EPA method that I've mentioned, with options for varying levels of moisture in your sample. This again is another feature which makes the system very simple to run, all while being method compliant. The final step of the workflow is to simply open the vessels. This can either be done by hand or by the dedicated tool. Here you can see the dedicated tool opening the vessels and removing the glass vials. Here, the samples can then be taken for pre-analytical workup steps and subsequent analysis. These pre-analytical workup steps can include filtration using filtration systems, as well as concentrating your samples using a multi-positioned concentrator, such as the Multivap 10. We do offer a range of systems to support improving the efficiency of the entire workflow for organic pollutant analysis. So if any of this is of interest, please do get in contact. So now we've covered the Ethos X system and its workflows. I wanted to touch on some real world examples as well. The first of those being a microplastics case study. Specifically, I'm going to talk about tire wear particles, or TWP. These are one of the most common types of microplastics found in the environment and potentially pose a significant risk to wildlife that ingest these particles. Recent studies have linked the presence of additives leaching from these microplastics to the death of fish species such as salmon and trout in the United States and Canadian rivers. One of the additives recognized to being more accountable for its toxicity is 6-PPDQ, the oxidized quinone form of 6-PPD. This compound is widely used as an anti-aging agent, not only for tires, but in the rubber manufacturing sector globally. Its mechanism of action involves the migration to the object's surface, where it scavenges ozone and oxygen, preserving the material from wearing. The UK Centre for Ecology and Hydrology recently published a comprehensive study on the field with the aim to detect and quantify the occurrence of different microplastics in the UK river and sediments. This included the assessment of TWP through indirect quantification of 6-PPD, which was chosen as a molecular marker due to its particular chemical structure and persistency in the environment. Microwave-assisted extraction proved to be a reliable and effective technique to obtain extractions of these types of additives from the treated sediments and soils. To perform this microwave-assisted extraction, the group used the Ethos X system with the FastX24 rotor. So the sediments were collected in 3 replicates from 2 different sites along UK rivers. The first being the River Irk in Greater Manchester, which is an urban site, while the second being a rural site on the River Thames in Oxfordshire. 4 grams of field samples were homogenized and dried, then transferred into the glass disposable vials of the FastX24 rotor. For the recovery studies, all the sediments were spiked with a recovery standard of D10 fluoranthene, an analogous compound of 6 ppd. 25 ml of solvent mixture was added. This was DCM acetone in a 1:1 ratio. The extraction procedure was carried out using the method which can be seen in the top right-hand corner of the slide, with a 15-minute ramp to 80 degrees and a 15-minute hold at 80 degrees. After extraction, the samples were filtered and concentrated with a step of cleaning through size exclusion chromatography prior to analysis on a GCMS system. The recovery results obtained on the recovery standard in every sediment were excellent, with the mean recovery being 95.8%. The results of the extraction of the 2 types of sediment can be seen in figure 3 in the bottom right-hand corner of the slide. And as you would expect, the rural site concentration of 6 ppd detected was substantially lower than that of the urban site. The concentration of 6 ppd at the urban site detected was 12 micrograms per kilogram, while at the rural site it was 1.02 micrograms per kilogram. This case study highlights how the use of the Ethos X with FastX24 rotor, with all its unique features that we've discussed today, makes for an innovative solution for extraction of a wide range of analytes and additives from soil and sediments for environmental testing labs. The quantity of sediment, due to the capacity of the glass vials we've discussed, can be increased or decreased in a range of 2 to 30 grams of sample, enabling detection of analytes on trace or ultra-trace levels. Additionally, the Ethos X enables simultaneous solvent extraction of up to 24 samples, in this case going from weighing to filtration steps in only 45 minutes. This offers extraction throughput of over 200 samples in an 8-hour workday. The next case study I wanted to talk about was the chemical group dioxins. Dioxins are a highly toxic chemical group and pose a serious public health risk. According to the US EPA, dioxin and dioxin-like chemicals have been associated with adverse health effects in the population. Dioxins are formed unintentionally through many industrial processes which involve chlorine. For example, this could be waste incineration, chemical and pesticide manufacturing, and pulp and paper bleaching industry. Dioxin is a general term that describes hundreds of chemicals that are highly persistent. The analysis of this class of pollutant is fundamental for environmental and human health protection. Many solutions for the extraction of dioxins are available, but a common and very critical issue is not just the sample prep technique itself, but the memory effect felt in extraction cells. In this case study, the use of the Ethos X with the FastX24 rotor is designed to overcome these challenges with the use of the disposable glass vials as extraction vessels. This approach ensures great analytical blanks and completely avoids the memory effect. In this case study, a sandy soil standard reference material was weighed directly into the 100 ml disposable glass vials. Solvent was added and the vials were then sealed. According to the moisture content of the sample, one of the built-in EPA 3546 extraction methods was followed, and after extraction, pre-analytical workup steps were followed by analysis on the GCMS system. As you can see from table 3, this case study shows excellent recovery of dioxin compounds with great reproducibility. The aim of this case study was really to highlight the use of the disposable glass vials to prevent carryover. And if you look at the results of table 4, this shows the blanks of the following run with a brand new disposable glass vial. The data shows that using the Ethos X with the FastX24 rotor not only offers you fast extraction with high data quality, but also overcomes the challenge of memory effects felt when extracting these types of tricky compounds, ensuring accurate and precise results. The final case study I wanted to talk about was PFAS, a very hot topic at the moment. You may have seen in the news yesterday that there was an article published about this persistent chemical in the UK rivers. It's a very hot topic at the moment. PFAS is per or polyfluoroalkyl substances. These are persistent chemicals found almost everywhere. These can be found in soil, water, food, and air, and require precise monitoring methods. As we have discussed, microwave-assisted extraction is widely used for sample preparation for organic pollutant analysis, with that capability now being extended to PFAS using this XTR44 rotor. Well, the focus of today's webinar has been on extraction using the FastX24 rotor. The Milestone microwave cavity offers flexibility with the option to customize the rotor that is at the heart of your system, depending on your lab's needs, be that extraction of pollutants, trace metal analysis, or even microwave ashing. All of these sample preparation techniques are possible on a single Ethos system. The XTR44 extraction rotor can accommodate up to 44 samples per batch, with simple workflows using commercially available polypropylene centrifuge tubes in various volumes as the extraction vessels themselves. By keeping the samples in the same tube throughout the process, any potential contamination is minimized. Additionally, the dedicated microwave configuration meets requirements for EPA method 1633, all while providing a 70% reduction in sample extraction time. The rotor designed specifically for PFAS analysis ensures that the vessel components in contact with the sample are all PFAS free. Using disposable vessels, much like the glass vials that we've talked about, eliminates the need for cleaning and prevents carryover felt between runs. This approach significantly reduces contamination risk and streamlines the sample preparation process while providing excellent recoveries versus other techniques such as shaker table extractions. So just to summarize today, we have discussed the Ethos X system for environmental extractions using microwave assisted extraction. This system offers easy handling with simple workflows. The system using the FastX24 rotor has high sample throughput with the capability to extract 24 samples simultaneously. The system has great temperature homogeneity through a unique vessel design. This, coupled with the contactless temperature control across all vessels, provides consistent and reproducible data. The Ethos X system has low running costs and minimum solvent usage, offering you a great return on investment. And like we just talked about in the PFAS case study, flexibility is at the heart of the system. You can use the system for PFAS analysis, extraction of organic pollutants, digestion, and even microwave ashing. Thank you very much for attending and listening. Any questions, please?
Thank you, Hemi. So at the moment, we've got no questions come through. What we'll do is leave the session open for a couple more minutes, see if any questions come. If not, we will end the event there.
Great.
So it doesn't look like we're going to have any questions. So in this case, I will take the opportunity again to thank everyone for attending. In fact, just as I said that we've had a question come through, will a copy of the presentation be sent across? And the answer to that is yes, it will. So following the event, everyone who's attended will automatically get a link to view this session. But yes, with that, thank you again, Hemi. Thank you again to all our attendees for joining us this morning, and have a good day.
Everyone.
Thank you.